In this video, we're going to talk about a new unit of measuring angles called radians, right? So you should be familiar at this point with degrees, right? So for example, if you have let's just pretend that this is a perfect 90-degree angle, right? So this is the right angle. So you know that this is going to be 90 degrees. If you have a straight line, right, we know that this is going to be 180 degrees and so on and so forth, right? So we're probably familiar with working out angles in degrees, but now let's talk about a new unit of measurement called radians. So on your screen, I have a definition, right, which says 1 radian is the angle of a sector of a circle when the radius equals the arc length of that sector. Now, let's just pause, right? Because this is a lot of words, which might not mean a whole bunch, which might be confusing. So let's break it down, right? Before we talk about the radian, let's talk about a couple of things that we've mentioned in this definition, right? The angle of a sector of a circle, right? So now what is a sector of a circle? So let's say, for example, you have this circle here, right? And any circle, right? So we're going to draw from the center. Maybe it's just about there. Any circle has a radius, right? Which goes from the center to your circumference. Essentially, a sector is, if you're thinking of a circle as a pizza, right? Or cake, a sector is the slice of that circle, of that pizza, of that cake, whatever it is, right? So this area over here, let's just color it in. This area over here, I hope you can see that. I know it's yellow, but that would be the sector of a circle, right? So a sector is basically a piece, right? It's a portion of the circle, right? So it's the angle of a sector of a circle when the radius equals the arc length of that circle. Now, what does this word mean? Arc length. Right now, if we've taken a piece, right, so we now know what a sector is. The arc length is the portion of the circle on that sector that runs along the circumference. So if we have this sector, the arc length is basically the distance that's going along the circumference. So that would be our arc length. Right. So those are the two key definitions that we need to know before we really dive into what we're talking about when we're trying to define what a radian is. So now let's go back to the definition of the radian, right? So now we know that we have our radius, which we're going to denote with an R. So both of these are radii, right? So we've got radius here, and then we're going to put our arc length as S, right? So this is our arc length. Okay, so now this sector then has this angle, which we're going to call theta, right? As we said, we know degrees, right? So the angle in degrees could be 30 degrees, it could be 60, whatever it is. And we know that if it goes all around the circle, it'll be 360 degrees, right? So for degrees, we should be familiar with those in a circle. But when it comes to radians, now let's now go back to the definition of a radian. A radian, 1 radian, is basically the angle that you create when the radius is equal to the arc length. So if your R is equal to your S, then you have 1 radian, which I'm just going to call rad, actually. That's the denotation for radian. So if your R is equal to your S, right? If your radius, so let's just say your radius is equal to 5 centimeters, and your arc length is also equal to 5 centimeters, right? So this length is 5 centimeters, then the angle that you create is 1 radian. All right. So what if we have what if I have two sectors, right? So let me just remove this, right? If I then create another radius over here, like this, right? Let's just pretend that this is the same length, right? Which basically is still, obviously, because it's going from the center to the circumference, so we know that it's R. But again, if our arc length for this second one as well is going to be the same as the radius as well, right? So if this arc length is also equal to R from this point to that point, that means this is also another 1 radian, right? So which means now in total for these two, so let's just create this. So that means from here all the way up until there, we have a total of 2 radians. And if we add another one, it's going to be 3 radians and 4 radians and so on. So what this tells us is actually the radian is, the angle in radians is basically going to be whatever your arc length is divided by r. Now, the question is, where did this come from? Where it came from is when we had the example where we said the arc length was 5 centimeters, the radius was 5 centimeters. This gave us 1 radian, right? When we doubled this, right, so that we still have, because remember your r doesn't change, it's the same circle, it's going to have the same radius. But if we double the arc length, right, so if we now have 2 sectors on each other, which means now you have this arc length and that arc length, right? So in total, your arc length is now 10 centimeters, right? So now you have 10 divided by r, which is going to be, or at least divided by 5, which is 2 radians, which makes sense on our diagram, right? Because the moment we had 2 sectors, we had one sector with an angle of 1 radian, another sector with an angle of 1 radian. So if we join those two, which means we have 2 arc lengths, right? That means we now have 2 radians. So essentially, what we're going to now do, another definition of a radian is going to be, the angle in radians is going to be the arc length divided by the radius. So let's just do theta in radians is equal to your arc length divided by your radius. Right. So the most important thing when it comes to, or at least one of the most important things when it comes to radians is being able to relate them to angles and degrees, right? So that then means, right, if we now need to know, okay, cool, we now know that 1 radian is when the radius equals to your arc length, right? And we can simplify it based on this equation, which essentially is going to be theta is equal to arc length divided by the radius, right? So if we stick with this, then, you know, we're good to go. Now, what we now need to do is to say, okay, when it comes to circles, when it comes to degrees, I know my standard angles. I know my 90, my 180, my 360. What are those angles? We now need to be able to relate those angles to radians, right? So angle of a full circle in radians, right? The angle of a full circle in radians, right? We're just going to use the exact same equation. Our equation says theta is equal to S over R, right? Where your S is your arc length, your R is your radius. So the S essentially is the distance that goes, distance along the circumference that covers your sector. So if we're looking at a full circle, it means we're looking at the full circumference, right? And we know from our earlier work, right, that in this case, if it's arc length of a full circle, that means it's going to be your circumference divided by R. And from, like I said, from our earlier work, and I'm talking earlier in terms of like IGCSEs, maybe before, we know that the length of the circumference is 2 pi r. So it's going to be 2 pi r divided by r. So these two r's cancel. So that means your theta for full circle is going to be equal to 2 pi radians. So this means that we now have a relation, right? We now know that 360 degrees, so let's just say therefore, 360 degrees is equal to 2 pi radians. All right. So what we're going to do is we're going to stop here, right? Because this is a completely new concept, so we don't want to introduce too many things at one time, right? But the most important takeaway in this video is to be able to use this formula, right, Oh, okay, that does not look pretty. Okay, but let me write it like, I'm just going to do this. Just going to start right there, right? So if as long as we know that your theta in radians is the ratio between your arc length, it's actually this one, your arc length and your radius. And then as long as you also know that your 360 degrees equates to 2 pi radians, because now we also now need to convert from degrees to radians and then vice versa as well. So those are the two most important takeaways for this video, right? And what we're going to do in the next couple of videos, we're going to work through just some examples on how to convert from degrees to radians, radians to degrees, and then we'll look into some, how to calculate arc length, how to calculate area of a sector, and so on. And then, fortunately, this is a very short section, so then we'll go straight into exam examples. All right, so hopefully this makes sense, and I will see you in the next video.